We are working on examples for section 4. We need to turn a list of numbers, also called a distribution of numbers, into a box plot and find some related information about the spread along the way. I'm going to zoom in to that list of numbers, so I'm going to make that the main focus of where we're starting here. What we're trying to do is actually divide this into quartiles or quarters. So we want to divide this list of numbers into 4 chunks. And the easiest way to cut things into quarters is to cut it in half and then cut each of those halves in half as well. So that will leave you with 4 pieces. So what we're going to do is work our way towards the middle. So I'm going to count our way towards the middle. So we have 1, 2, 3 on this end, 1, 2, 3 on this end. 1, 2 on this end, 1, 2 on this end. And I end up getting to the middle number. So in this case it is 10. So 10 is the middle of my list. And in fact that is called the median. So we can write that down in the median spot right there. Now I have 2 lists of 5 that I have remaining. And so with my 2 lists, I'm going to find the middle of each of those. 1, 2, 1, 2, and there's my middle. 1, 2, 1, 2, there's my middle right there. So now I just found the middle of each of the halves. And if you think of the end of each quartile, this first quartile is called quarter 1, and so we can call that Q1 for short. The second one, the median, would be the end of the second quartile, and then the third one here is the end of the third quartile, and that's going to be 14. So we zoom out a little bit. Quarter 1 is 9, quarter 3 is 14. And then finally we go all the way out here, the minimum and the maximum. And the minimum value here is the lowest number, so that's 2. And the maximum then is the highest value, so that's going to be 20. So now we're going to use these things that we calculated. We won't need to go back to that list anymore. We're going to use this list of numbers we calculated here to do everything else. The range is how far apart, right here, the range is how far apart we go from the highest to the lowest number. So it is how far apart we are from there all the way back to there. And so 20, our high, our max, minus 2, our minimum, is 18. So our range is 18. If we want to find our interquartile range, we need to go in between the quartiles. So we have a quartile and a quartile, and we want to figure out how far apart those are. So when it says range, we think how far apart, and when we think interquartile, we don't say end to end, we go between the quarters. So 14 minus 9. Sometimes you'll see this called the IQR. It just is an abbreviation for interquartile range, the range between the quarters. And again, 14 minus 9, I didn't actually solve that yet, it is equal to 5. So we subtract that, we get 5. That is our IQR. This is our range here of 18. Last thing we need to do with all this is to draw a box plot. And a box plot is going to have dots on the end and then a box in the middle. So we're going to start out with our list of numbers here and try to figure out how do we number this number line so that everything will fit. And it looks like I have numbers 2 through 20. And this little thing here, this number line, 6, 7, 8, 9, has 11 little tick marks. So it looks like if I counted by 2s, everything would fit. So if I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Yep, all of our numbers will fit on this number line if I count by 2s. So I'm going to start out with a dot at the 2. Start out with a dot up here at 2. My quarter 1 of 9 is where I start drawing the box. And then I have a median of 10, so I draw a line right there. And at 14 is my quarter 3. So I'm going to take these here and turn them into the box. So I had 9 for my quarter 1, 10 for my median, 14 for my quarter 3. My maximum is 20, so that's going to be out here. This is often called a box and whiskers plot because the middle is the box, and then these here that go all the way to those dots for the minimum and the maximum, those are the whiskers. I'm going to go through one more quick start of an example for this next one here, because there's a couple parts that I think can be tricky. So we have our list of numbers. It kind of wraps around, and we want to figure out where the middle is, the median. So we're going to work our way towards the middle. So I'm going to go 1, 2, 3 on that end, 1, 2, 3 on this end. 1, 2, 3 on that end, 1, 2, 3 on this end. And I end up with 187 being my median, because that ends up being the exact center of my list. Now I need to find the median of each half. So I go 1, 2, 1, 2, one more, and I end up right there. But there's no number there because it's an even sized list. I can't find the middle because there is no middle. That might be a problem. Whenever that happens, you end up having essentially two middles. And when you have two middles, you need to find the average of those numbers. So the easiest way to do that is to take 100 plus 135 and put it in your calculator and divide it by 2. So 100 plus 135, do that in your calculator to get 235. Divide that by 2, and you're going to get 117.5. So you just have to average those two numbers in order to get that quarter one. So 117.5. Now we said our median was 187. You have to do the same thing over here. You have to figure out, okay, if this is going to be the middle over here, what is the average of 200 and 200? You could add 200 plus 200 to get 400 in your calculator and divide it by 2. Or you could just realize, hey, they're the same number. I bet the average of the same things is just going to be the same thing. So in fact, the average of 200 and 200 is 200. And then the rest of it follows the way that we did before. You find your minimum and maximum and kind of keep working your way through. If in any given problem you were to have a list of numbers like this, and the whole list was even such that the median ended up with this double situation here, you would actually split the list completely in half into two parts to find your quartiles and have the middle and the middle like that. And you would not throw out the middle number. You would just have both numbers stay on their particular sides. So treat it kind of like we did in this example here. Good luck finishing the rest of this section.